Okay, we're going to go ahead and look at properties of integrals. So we have 5 different ones that we're going to write down. First one, from a to b, f of x dx. So that's the area under the curve from a to b equals, we're going to change something. We're going to change the order, and we're going to say from b to a, f of x dx. And what happens, because the direction changed, it's going to be negative. Our second property, from a to b, f of x dx, plus from b to c. So if I add the area under the curve from a to b, and then add the area under the curve from b to c, the result is the area under the curve from a to c. Notice that the b is the part that's connecting them. Property 3. From a to b, this is a coefficient c times f of x dx. So this represents the area under the curve from a to b. And we have the curve, but we have a multiplication in front. So this will equal, the coefficient can come in front, and then we multiply area from a to b, f of x dx. This coefficient can move from inside the integral, right here, to outside the integral. All right, so now we have the integral from a to b of f of x plus or minus g of x. Notice that the integral and the dx, that's the start and that's the end of the integral. We want the area under both pieces on the inside. And when we had derivatives, we took the derivative of each part separately. We're going to do the same thing with the integral. From a to b, f of x dx, plus or minus the integral from a to b, g of x dx. Separate a to b, dx, dx. So we have the beginning and the end, and then the f of x in the middle. From a to b, f of x power. Notice it kind of looks like chain rule with the substitution here. What we can do is change the order of the operation, and we can actually evaluate the integral before you do the power. And then there's actually one last one that we're going to put in here. That's going to go from a to a, f of x dx. The area under the curve from a to a would have no area, so it's 0. Most of the properties that we're going to use are going to fall in this category here. The first one, where the order changes. The second one, where we have 2 parts make a whole. And then mostly the fourth one, where we're going to separate over pluses or minuses and then calculate the integral. So let's look at the first one. Okay, notice that we don't have any pictures and we don't have any equations to work with. There's no way to type these in the calculator. So we have f and g and h, and they're giving us starting and ending points. Okay, -2 to 5, f of x plus g of x. So I'm going to use property number 4. -2 to 5. And as I'm rewriting this, I'm hoping to write the integrals as one of the 4 items that are given to me. negative 2 to 5 f of x. Okay, 18. So we're replacing it with the quantities, negative 2 to 5 g of x. And so the result is 23. Okay, 3 of them, and subtraction. Okay, negative 2 to 5 f of x dx plus negative 2 to 5 g of x dx minus, right, so the negative comes in front, that's kind of like the coefficient one, negative 2 to 5 h of x dx. And we look, so that's 18 plus 5 minus 11. 23 plus 11, so 34. Let's look at the last one. 5 to negative 2. Oh, so that's backwards. Notice that all of my integrals start at negative 2. So we're going to use the first property, and we're going to change the order. Negative 2 to 5 minus 4 g of x dx. Okay, so that's property number 3. The 4 is going to come in front. Still negative. Negative 2 to 5 g of x d of x. Okay, now this one I can look up. Negative 2 to 5 is equal to 5. Negative 20 is the result. Let's look at the next row. Oh, this is different. Instead of having two functions, I have g of x and a plus 2. Negative 2 to 5, so it's in the same order. So I'm going to start by separating it. Negative 2 to 5 g of x dx plus negative 2 to 5 2 dx. Well, g of x dx comes from here, and that's a 5. This one, this is actually worksheet number 4. Notice that this is like y equals 2. From negative 2, 1, 2, 3, 4, 5, all the way up to 5. Well, that is a rectangle, 7 by 2. So the area is 14. So the result is 19. Let's go ahead and try the next one. Notice it's a similar format. We have a negative 6 here. So let's separate it. Negative 2 to 5. F of x dx. Now I'm going to bring that negative in front. Only one negative. 6 dx. Okay, this is like worksheet number 4. Sketch the graph. So this is 6 high. Okay, 1, 2, 1, 2, 3, 4, 5. Okay, so that's 7. So it's 42. 7 by 6 is 42. Now negative 2 to 5 f of x dx is 18. 18 minus 42, negative 24. Okay, last one. 5 to 8 f of x dx. Well, the only thing I notice is that I have negative 2 to 5 and negative 2 to 8. Those are the only two quantities with f of x. Well, I have a 5 and an 8. So I'm going to write what I do know. Notice that negative 2 is the most left and positive 8 is the most right number. So negative 2 to 5. F of x dx plus, it's important that the 5 connects. Okay, negative 2 to 5 and 5 to 8 will equal the integral from negative 2 to 8. And what we're trying to do is have one unknown integral and then two that we do know. Negative 2 to 8. So my notation is a little bit bad. So f of x dx. Okay, fill in what we have. This is 18. This is an unknown amount of area. And this is 0. Oh, well, a equals negative 18. This integral equals negative 18. Okay, let's turn the page over. Go ahead and try the next 3 questions and then hit play when you're ready for the answers. I notice that the order is backwards, and so the first thing we're going to do is switch the order. Now I'm going to separate it. Be careful to leave the negative in front of both integrals. Okay. See the grouping symbols that I left? That negative applies to both integrals. Negative 2 to 5 g of x dx. Okay, so if I look that up, it is positive 5. Okay, minus negative 2 to 5 3 dx. Okay, so this is like worksheet 4. It's not something that was given to me. That's a horizontal line. Okay. Negative 2 to 5, 3 high, so that's 21. Minus 21, negative 26. Okay, the order is backwards, so we're going to go ahead and switch the order, just like we did in this first one. I'm going to skip all the way to this part right here. Negative 2 to 5, okay, f of x dx, minus negative 2 to 5, 6. Okay. This is the part, right, separated. The order changed with the negative in front. So let's draw on this missing step. Negative 2 to 5. F of x minus 6 dx. Then I separated the integral. Now I'm going to distribute. Okay, looking up from the first page, negative 2 to 5 f of x dx is 18. Oh, that's a horizontal line. Okay. 7 times 6, 42, plus 42. Okay, 5 to 8. Well, let's separate it because I have this extra 3 over here. But they're in the wrong order, and so I'm going to change the order before I separate. I'm working my way outside in from my properties. Okay, now let's separate. Negative 5 to 8 f of x dx minus, oh, that's a positive 5. Okay. 5 to 8. Okay, I notice the second part is a little bit easier. 5, 8, and it's 3 high. 3 by 3, so that's a 9. Okay. 5 to 8. Well, I notice that I have negative 2 to 8 and negative 2 to 5. And so I'm going to break up this part right here and see if I can't figure it out. All right, negative 2 to 8. And I'm going to use simple notation here. Equals negative 2 to 5 plus 5 to 8. All right, start and stop. Start, middle, middle, stop. Okay, that goes in order. And so if I look up on the first page, negative 2 to 8 is 0. Negative 2 to 5 is 18. And 5 to 8 is the unknown area. There's the integral that I was looking for. So this is minus negative 18. Keep that minus 9. And so we end up with, oh, not 27. We end up with positive 18 minus 9, so positive 9. All right, next set. Give them a try, and then press play when ready. 1 to 4. Okay, so these are all for f of x. I'm going to go ahead and just draw a quick number line here and see what that can tell me. So the most left number is 0, 1, 2, and 4. Right? These are all the middle points. Farthest left, farthest right. Well, 1 to 2 is negative 1. But 0 to 2 is 2. Okay? Probably means this is 3 because 0 to 2 has to add up to 2. And 2 to 4 has to be 7. Okay? Right? That was the transitive property. That was property number 2, where I put all these little pieces together. 2 to 4 is 7. 1 to 2 is negative 1. But 0 to 2 is 2. That leaves me with 0 to 1 being 3. All right, so let's see if we can do this with the notation. 1 to 4 visually should be a 6. Let's see if we can write it out. Here's a starting point. So we have 1 and 4, and 2 connects them. So 1 to 2 plus 2 to 4 equals 1 to 4, connected by the middle 2. A to B and B to C equals A to C. Negative 1 plus 7 equals 6. Okay, 0 to 4. Start and stop. 0 to 2 and 2 to 4 equals 0 to 4, and the 2 connects. 0 to 2 is 2. 2 to 4 is 7. 0 to 4 is 9. 0 to 1. Oh, that's a little bit tricky. Well, the only two integrals that have 0 and 1 is the first one and the second one. But notice that 0 and 2 are the bigger, right? There's the most left and the most right. 0 to 1 plus 1 to 2. it's important that the middle number always connects the start and the stop of the other integral. Most left and most right. Okay, well, which ones do we know? We know this one. This is the unknown area, and 1 to 2 is -1. That means that the integral area we are looking for is 3. Okay, try the next 3. Press play when ready. Go ahead and split them up. Okay, 0 to 1, f of x dx. Oh, I just did that number 27, so let's go ahead and copy our work. Oh, that's a graph. That's a 1 by 1 square, so we get 4. Okay, 0 to 2. Oh, there it is, top left, so I have it. So let's split it up. 0 to 2, f of x dx, plus 0 to 2, 3 dx. This one is 2. This one is a graph. 6 units, plus 6. Okay, last one, 2 to 4. Oh, good. That's the third integral that's given to me. Okay. Split it up. 2 to 4 f of x dx minus 2 to 4 2 dx. Right? This one is 7 minus, sketch the graph. That's a 2 by 2, so that's 4 units. So 7 minus 4 is 3. Okay, you have Delta Math assignments to work on, and if you need more practice, you have homework worksheet 5, the front, which is just reading the areas off the chart, and you have some property practice on the back. I would suggest trying at least numbers 7, 8, and 9. All right, good luck. See you Thursday.